Atari fans. 13 years ago we released the cart, a 128 megabyte flash cartridge for the Atari 8-bit computers that can emulate 36 other cartridge types, the most prominent and some obscure ones that were known at the time. And after all this time, there have been many updates to the software, but not to the hardware. There were 2 revisions of the hardware. So the V2 came with gold-plated contacts and configuration lock to make it more compatible. But other than that, there was no functional change, especially because all the gates in the CPLD, they were already used up by the supported features. And in all these years, he has refused to do anything about it and said it's working, I won't touch it ever again. Well, ever again lasted until some weeks ago when Vega and his team released the excellent Street Fighter II conversion for the Atari 8-bits. And that one requires a 4 megabyte cartridge. For good reasons, because there are a lot of samples and excellent graphics in it. And somehow this triggered Hias to go back, revisit the logic, and really rearrange it in a way that he finds some free transistors that he can use to add one more ROM emulation for a 4 megabyte cartridge to the cart. So good news is, all you the cart owners, there is an update for you, and you can enjoy Street Fighter II on a physical cartridge. It wasn't that easy to get the new logic onto the cart, so I attended a midwinter meeting, and together with 3 other guys we managed to set up a machine, an XP machine with very old software and the FujiNet and all that, to after 3 days with 4 people in the end get it onto the cart and prove that it works. So yeah, despite the bad quality of the iPhone filming a CRT, you see it's running and it's from a cartridge like this. So what we plan to do is we plan to prepare a Windows XP machine that we can take to our next meeting. So if you want to come by with your other cart, you can get the update. It will not take more than 30 seconds typically, provided you have all the preparation done. And that's what I'm going to show later in this video if you want to do it yourself. There is a new version of the Cart Studio that is published now, and that contains the support for this new cartridge type. The documentation has of course been updated to reflect this. So what does it mean? We have a new cartridge type, which is the cartridge type 63, and that corresponds to the card mode 37. That's what you require to run Street Fighter 2 or maybe future cartridges that require flash card 4MB format. But to make it work, it's not sufficient to just update the card via the usual flash routine. You also need to update the logic. That's what I'm going to show later. Yeah, the corresponding sections in the documentation and the troubleshooting have been updated. He has also provided a fix for start bank commutation of 16.4 of cartridges that use 16K bank size. Normally it didn't disturb. I had no problems reported because normally banks start at bank 0 and there it doesn't make a difference. But yeah, there might have been issues in the past. They should be fixed. And also the software to flash the card has been updated, so it uses the latest MyPicados and high-speed SIO for best performance and compatibility. So this video is about showing you how to update the CPLD logic. So what is a CPLD? It's a complex programmable logic device. It's a kind of flexible hardware that you can update by, nowadays people would say, flashing new logic to it. Technically it's not flashing, but it's a similar process via an interface called JTAG. JTAG is a serial protocol to do in-system programming of such logic chips. The difference between a CPLD and FPGA is that CPLD really statically contains that logic, so the moment you switch it on, the logic is there. In a flash, in FPGA, you normally have some serial flash where during the power-up process the logic needs to be loaded from the flash into the FPGA, which means that typically they have some startup time while the CPLD doesn't. On the other hand, FPGAs nowadays are much more powerful in terms of the available number of gates. Yeah, so the disclaimer for everything that I say from now on is only do it if you really know what you're doing. Be careful, if you connect something incorrectly, it may simply fry the CPLD and the card is crap. Okay, so the assumption is that we have a Xilinx USB platform cable like the one that's depicted here. It's one that I bought some years back. Oftentimes you get clones, they should equally work well, or similar things. The process itself should be the same. And yeah, what we did is we did it on Windows XP and we did it on Windows 7 because they're the drivers for this USB connector actually exist. We also did it with a rather old version of Impact from the ISE 10.1. Reason is that if you have an older version, the chip used in the card is not yet there. If you use newer versions, it might no longer be there in the list of supported chips. So what do you need in addition to this hardware? You need the corresponding ISE design suite that you can download from the ISE archive. You can scroll down here. There is version 10.1 and you need the full product installation, which is here 5 and effectively on your hard drive about 6.2 gigabyte. Don't be surprised, you don't need all of them later on your hard drive, but the download is as large as that. To perform the download, you will also have to register at AMD with a simple registration process because of export control. But yeah, it's really not difficult and it's not an issue. Once you did that, you can additionally download the latest version of the CPLD logic. So you see there were 3 revisions, the initial one of the very first release, and then for the V2 we added the configuration lock feature to prevent software from unintentionally disabling the card while it runs. And the new version, the latest version from March 22nd, that contains the update for the 4 megabyte flash cartridges. Interestingly, the download that you have here, these 6 point something gigabytes, they are a tar file. So if you're on Windows XP, you will not be able to uncompress it directly using the operating system. There is a link to an additional GNU tar for Windows that allows you to uncompress the file. If you have that, then you can use tar xvf for extract verbose from file, and then this tar file will be turned into a folder of probably the equal, not probably, of about the same size on your hard drive. So you at that moment occupy 12 gigabytes of data on your hard drive, but that's not permanent. Yeah, you do the same for the, not the same, but you can download the software here, and that's a zip file. So if you open that here, then you can, using Windows, uncompress it to a folder. And in that folder, the one file that you will later need is that, where is it? The card, should sort it. There is the card JAD file. That's the one that you're going to later need from this folder. Okay, once you unzipped it or untarred it, there is a setup executable program in the ISEDS folder. Be careful to run it with administrator rights, otherwise the installation of the drivers won't work. And you press next. On the next screen, you are confronted with a prompt for the registration ID, which you do not need. Yeah, so you don't need to fill this field. You can just leave it empty and press next, because we don't want to use the full ISE design tools. All we want to use are the standalone programming tools. And if you haven't entered a registration ID, then that's the only option that you can select here. Yeah, next, you press next again. There are the license terms, part 1 that you have to accept. There are the license terms, part 2 that you have to accept. Then you can use the standard folders for the installation. And it also creates a program folder in your start menu. Then that's the confirmation about the about the needed disk size. You see about 1.5 gigabyte are then actually required for the standalone tools and not the rest of these 6 gigabytes. What I would recommend is to also do that. I haven't tested whether it works without, but I would doubt it. That it also extends your environment with the environment variables later used probably by the program. Then in the installation option, we want two things. We want to install the update program, and we want to install the drivers for the USB cable. Then we get a summary of all the choices that we did. We click install, and then the program terminates and we are fine. So the software is installed. You can now plug in the USB cable, and you should see 3 devices being recognized by the operating system and then available in the device manager. Power your Atari computer off. We will need that one in a moment. Then we plug the card into your Atari computer and make sure you plug it in the right way, because typically if you have it open, it is difficult to see which is the front, which is the back. So be careful to have the Xilinx Link chip facing down and actually the card chip pointing upwards to you. And so what's next? Yeah, we have to connect the programmer to the card. If you look at this, then I see there is a picture missing here. Give me a second. This should be the card JTAG. JTAG it is. There it is. So this is how it should look like from the top. So if I'm now an XE computer, I plug this into the back of the cartridge port. So here we have a total of 8 pins. They are clock, ground, not sure what that is, selection, 2 not connected pins, TDI for in, TDI for out, and VCC for the sensing if there is power on the board. Yeah, here you see this diagonal chip. That's a memory chip with the SRAM. So if you look at it this way, then you are right. So here again is the overview of the pins that you need to connect and the 2 that you don't need to connect. You may either put a connector directly in here. So that's what I did in one of the cards because it was easier. You can also solder permanent connectors to the board, which is a bit more effort, and you have to be careful if you solder it not in the right angle or they are too long, then the shell of the card will not close anymore. Yeah, so be careful with that. But normally we don't need to update so often, and updates only take 30 seconds. So just holding the connector there in the right direction and flashing and updating it should be just fine. What I also provided is a download. If you have a Brother Peach Hutch, then you can print these adhesive labels that I have here in my images. So next is we power on the Atari computer with the card plugged in, and the moment there is power on the Atari, you should see that green status LED here yeah, lighting up. Before that it would be red, and the status LED turns green if there is power and the power is correct. So then the installation is completed, all the wires are connected, so now we start the program. You find it here in the program menu, and the program is called Impact. When you start it for the first time, it will prompt you to create a new project. So we create a new project. We select the default, which means a boundary scan via the available USB cable, so it detects what is connected currently to your computer and will create a matching project. Then you can select from the menu the chip that you want to add as a device via the Add Device menu, and you select the card JAD file from the card logic folder that we previously uncompressed. Then you click Program via the context menu. You get this prompt where you can do some additional settings. You don't need to change them, so by default it has Verify Active, which I would strongly recommend. and then you press OK, and then you get a success message. And depending on which USB version it is, it will take between 10 and 30 seconds. And after that, the card logic is updated. You can power off your Atari, unplug the Xilinx cable, and you're ready to go with the next update of the card software to make use of your latest features and play Street Fighter 2. Yeah, enjoy Atari and see you next time. Bye.